Welcome, ladies and gentlemen, to episode 41 of the Snowflake Snowpro Advanced Architect Certification In-Depth Training Podcast brought to you by Bright Flux. I'm Yakub Abdul Hakim, your guide through the intricate world of Snowflake. Today's in-depth discussion is dedicated to understanding key or column constraints in Snowflake. This episode is designed to arm you with the knowledge needed to ace your certification exam on this topic. To ensure we cover every detail, we'll dive into the essence of key and column constraints, their applications, and the impact they have on data integrity in Snowflake. Firstly, let's grasp the fundamental concept of constraints in a database environment. They are rules enforced on data columns to ensure the accuracy and reliability of the data in a database. Snowflake supports several types of constraints, including not null, unique, primary key, and foreign key, each serving a distinct purpose in maintaining data integrity. Starting with the not null constraint, it ensures that a column cannot have a null value. This is crucial for columns that must have a specific value for every record. For instance, an employee ID column in an employee table cannot afford to be empty as it uniquely identifies each employee. Interestingly, while Snowflake acknowledges the not null constraint for table creation and data loading, it doesn't enforce it during DML operations. This is an important point to remember as you prepare for your exam. Next, let's delve into the unique constraint. This constraint ensures that all values in a column are distinct. Consider an email column in a user table. Every user must have a unique email address. In Snowflake, when a unique constraint is applied, it effectively prevents the entry of duplicate values into the specified column, maintaining the column's uniqueness. Moreover, primary key constraints combine the aspects of not null and unique, guaranteeing that each row in a table has a unique identifier. However, Snowflake does not enforce primary key constraints but does utilize them for query optimization, which is a subtle yet significant distinction. Simultaneously, the foreign key constraint establishes a relationship between two tables. Although Snowflake supports foreign key constraints in table definitions, it does not enforce them, leaving the responsibility of maintaining referential integrity to the application layer. This approach reduces overhead on the database side but requires more diligence at the application level. Additionally, it's imperative to understand how these constraints are defined and modified in Snowflake. Definitions can be included at the time of table creation or added later through alter table commands. Knowing how to implement, modify, and remove these constraints is essential for architecture design and data integrity management. Especially noteworthy is the way Snowflake handles constraint information. Although it records and displays constraint definitions, it operates under a unique model that places emphasis on performance and flexibility, rather than strict constraint enforcement commonly seen in other database systems. To sum up, as we navigate through the complexities of key or column constraints in Snowflake, it becomes evident that understanding their purposes, applications, and limitations is fundamental for any Snowflake professional aiming for the Snowpro Advanced Architect Certification. Embrace the nuances of these constraints and let this knowledge guide your design and implementation strategies in the Snowflake environment. We've covered a lot of ground today, and I hope this episode sheds light on the intricacies of key and column constraints in Snowflake, helping you on your journey to certification success. Remember, the devil is in the details, and a deep understanding of these concepts is key to mastering Snowflake architecture. Thank you for joining me, Yaqub Abdul Hakim, on this educational journey. Stay tuned for more in-depth explorations of Snowflake in our upcoming episodes. Until next time, keep analyzing, designing, and optimizing with Snowflake.